Hello again. Another video. This one is going to be about the center of mass of objects and how to find it and some of the properties of the center of mass. So the definition of the center of mass is basically it's a point in the object where that we consider that all the mass is concentrated in that location. Now that depends on the distribution of mass. So in other words, if I take a uniform disk, filled in disk, okay, the center of mass will be right at the center. Okay, if I take a hoop, okay, the center of mass is right in the middle. Now you don't have to have matter to talk about this center of mass ideal. So this is kind of like an average of the distribution of mass, kind of, right? Now, what happens if I take this disk here that's filled in, and I make it so that this blue side is heavier? So now there is more mass to the right compared to the left. So my center of mass is no longer right at smack in the middle. It's somewhere in this blue shaded area. Now, if I apply a force directed right at the center of mass, this object will not rotate. It will slide, but it will not rotate because there will be no torque. Objects will balance around their center of mass. So I'll show you two examples. We're going to do a lot more in class. So the first one is if I take a thin object, like kind of like one-dimensional almost, right? To find the center of mass, all I have to do is that I put my fingers at the ends and start sliding and just let it go. Just go with the motion, right? And you're going to notice that at one point, you can't just keep sliding one finger without the other naturally just also moving. So I'm moving my left, my left, my left, my left, and my right is just going to start to move on its own. I'm not actually doing this, it's just happening on its own. And this should balance around the center of mass. So I'm close to the 50 with my right, okay? When my two fingers meet, that's the center of mass. So they meet at about like 49 and a half. I should be able to balance this at the 49 and a half, somewhere around there. Okay? And it balances right there. Okay? All right. For a 2D object, what you do is you hang it from different places. So you probably recognize what this is, right? You should. Okay? And you take a plumb line, a weight, right? And you just let it hang. So it goes straight down because of gravity. And we're going to put some, follow the line here. So you follow this line. So I'm just saying that the center of mass is probably going to be around, somewhere around here, it looks like. Okay? And you change the location, and you put this somewhere else. So maybe I'll put it right there. Okay? You do the same thing again. You just let it hang. I'm not doing it like with a lot of precision, but maybe in class we'll do it with a lot of precision. So it's around here, kind of. So my center of mass is right there. This shape, this is a 2D, not 3D. 3D is a little more complicated. You have to do a little bit of calculus and stuff to find that. Should balance around there, somewhere around there, right? Close. I didn't do it with a lot of, so I'll cheat a little bit, use two fingers. It should balance around there. Okay, that's how you find the center of mass. We say that it could be inside or outside. Now, in order for an object to be stable, its center of mass has to have support. So a very simple example, I'm going to get my basketball, right? If I take a basketball, right, if I just let it sit on a surface, right, it just won't go anywhere, right? Probably can't see it, so let me just move the video. Okay, there you go. Okay, it will just sit there because its center of mass has a base. Now, if I take this same ball, right, and I use a board, an incline. As soon as I put the ball on there, it starts to roll. And if you think about it, if you try to visualize this, you're going to see that the center of mass is kind of like leaning forward, is above this base here, this contact. Okay? That's why the ball kind of rolls, because there is a torque being generated around that base. Okay, let's go back to normal view. Okay. A couple of examples. We're going to do a lot of examples in class. So your center of mass is around your belly area, right? So if you try to stand on one leg, right, you always kind of like shift your hips so that your center of mass is right above your foot, right? So it has a support. Now, if you try to do it without shifting your hips, you just can't do it, right? So I'm trying to raise my leg without shifting my hips, and I'm just like, I don't have stability. All right, so that's quickly what the center of mass is conceptually. And we're going to do a lot of examples in class. Now, if you want to be stable, you can increase the base. That's why if you're riding, if you're on a train or a bus, and you want to be stable, what you do, you spread your legs. So you don't just keep them close to each other. You spread them out. So the base is bigger, right? Or you lower your center of mass. That's why people that are short are more stable. That's why in football, running backs are very hard to knock down, right? Okay, but someone who is tall, they have a high center of mass, it's very easy to topple them, right? The same thing with the SUVs. They're very easy for them to topple because they have a high center of mass compared to a car that doesn't have any height.